Hello friends, in this video I am going to show you the multisim simulation or visualization of MOSFET as capacitor. Okay, so you should know the concept of good capacitor and bad capacitor in MOSFET, which I already discussed in my previous video in detail. Okay, so if you don't know how to use MOSFET as capacitor, please go through the link given in the description. Okay, I will provide the required link. So the basic concept is, if we keep gate voltage very high in the positive direction, and if we short circuit the drain and source and body to ground, basically in that case the MOSFET will act like a good capacitor, and that's what I am going to show you. So first let me take some electrical components which is must required for this particular experiment. Okay, so obviously we require one MOSFET, so go to transistors and MOSFET, enhancement type, N type MOSFET I am taking, enhancement type 2N7000, generally we take this, so I am taking this only. And how I am going to show you that behavior of the capacitive action of MOSFET, that is, as you know, in series connection of RC, if you take output across the capacitor, then that circuit will basically behave like a low pass filter, right? So basically I am going to implement that same circuit, just instead of implementing the circuit using capacitor, I am going to implement the MOSFET as capacitor, and I am going to show you that that circuit behaves like a low pass filter, which will ensure that the MOSFET is behaving like a capacitor. Okay, so basically for that obviously we need one resistor, so go to basic, then resistor, take one resistor also, and obviously we require one AC signal source. Okay, so go to signal voltage source and then take AC voltage. Okay, so and obviously we require one ground, because without ground our circuit will not work. And first let us make the connection, then we will act according to our requirement. So rotate 90 degree clockwise, then see what I am doing. Source and body is already short circuited, just I am short circuiting the source and drain of this circuit, that is MOSFET also. And here one I am keeping one resistor, and here I am connecting with the gate. Here this AC signal source is grounded, and I am taking one junction by the shortcut key is Ctrl J, and take one junction, sorry, here also Ctrl J, here one junction just take and connect these two, and this becomes our circuit. But as you know from the concept of good capacitor and bad capacitor, or MOSFET behaving like a capacitor, what is that? That is basically the gate should be highly positive, but here we are applying AC signal source, so once it will go to positive, then another time it will go to negative, right? So basically what I am going to do, I am going to bias this particular source with a very high DC voltage, positive DC voltage, so that gate is always at very high potential, so that it behaves like a good capacitor. Okay, so Ctrl W, take one that is DC power source. Okay, and place it here. Now close this circuit and just open this particular wire and take it here. Sorry. Now connect these two and connect these two. Okay, so this makes our circuit. Obviously 12 volt DC source is connected, so obviously 1 volt peak voltage amplitude AC signal can never make it negative gate voltage, right? So basically this is our circuit. Now to observe whether it is acting like a low pass filter or not, I have taken Bode plotter, and see here you can easily get the Bode plotter, and I am taking the output across the capacitor, or basically this MOSFET connecting source and drain short circuited, and voltage is applied in the gate, and here the input is connected with the input signal. Okay, so input AC signal let us take only, and now just simulate. See, first let me reverse this. See here, although the circuit has its constant gain at low frequency, but as the frequency increases the gain keep on reducing. Okay, so obviously it behaves like a low pass filter, it is clear. And see, as you know from the basic concept of passive filters, that in a series connection of RC, if you take output across the capacitor, then that circuit behaves like a low pass filter. And here we are taking output across this particular connection of MOSFET, where we have short circuited source and drain and body, and we are connecting these three terminals with the ground, and we are applying potential in the gate, and we are applying very high positive potential. So this ensures that this particular circuit behaves like a capacitor, this particular connection of MOSFET. Suppose you want to decrease the cutoff frequency. So what is the cutoff frequency for low pass filter in a series RC combination? Correct, F is equal to 1 by 2 pi RC. So if we want to decrease this particular frequency of that is cutoff frequency, you can increase the resistor value. So suppose let me make it 100 kilo ohm. Okay, sorry, simulation is running. First pause the simulation and then 100 kilo ohm, then you just run and see. Now in this particular case, you just observe, see, cutoff frequency is decreased. Okay, so this is what ensures that this particular circuit behaves like a low pass filter, and this particular connection of MOSFET, this particular configuration where source, body, drain all are connected to ground or all are short circuited, and we are applying potential in the gate, this behaves like a capacitor. Okay, so whatever we have studied in theory exactly matching with the practical simulation also, right? So you can simulate this kind of circuits and check whether you have studied correct things or not, because obviously if you visualize some concept, it will be there in your mind for a longer time, and it is always good to visualize something. There is nothing wrong in that, right? So basically this is all for this video. Thank you for watching.